I want to welcome everybody this morning to the final presentations and recognition ceremony for the Oak Ridge Science Academy and the ARC ORNL High School Summer Middle Science Technology Institute. We're pleased to take this opportunity this morning to recognize the participating students and welcome their families, their mentors, and officials from Oak Ridge National Laboratory, the ARC headquarters, state offices, and ORAU. We appreciate the partnerships with the ARC and Oak Ridge National Laboratory to provide these opportunities for both the students and the teachers that are with us this morning. You know, this is the 26th year for the Summer Institute for High School Teachers and Students, and the 6th year that we've held the Middle School Science Academy. And our common goals for both programs have been to motivate students to continue their education and continue their STEM careers. In an effort to extend the reach of these programs to students throughout the 13 states of the Appalachian region, high school teachers from across the region are selected to participate in the Institute. This program expands the teachers' passions for teaching science, math, and technology, but also exposes them to cutting-edge research that can be transferred immediately to their classroom. So it's my pleasure to recognize your accomplishments today and to encourage you to continue your collaboration with the ARC, Oak Ridge National Laboratory, and ORAU. Students, we're counting on you to be the future scientific and technical workforce for our nation. And teachers, we're counting on you to continue to change the future of your students for the many years to come. But we want to thank all of you for your investment today in the future workforce of our country. At this time, it's my pleasure to introduce Dr. Tom Mason, Director of Oak Ridge National Laboratory. As the Laboratory Director, Dr. Mason is responsible for a diverse portfolio of science and energy research and development spanning fundamental research in physics, biology, chemistry through climate change, energy generation, and national security programs. Dr. Mason has a Bachelor's in Science and Physics and has a PhD in Physics from McMaster University in Hamilton, Ontario. Please join me in welcoming Dr. Tom Mason.
Well, congratulations on completing your summer research experience here at Oak Ridge National Lab. I hope you enjoyed working with us. I hope you had fun. And I hope you learned a lot. If nothing else, you probably had a chance to gain some perspective on how science and technology can contribute to solving some of the big problems that we face in the world today. Of course, as a Department of Energy lab, energy-related problems is a big part of our focus. But we take a fairly diverse approach, and actually looking at the list of research projects, I think it really does reflect the diversity of research across the lab in biofuels, nuclear energy, both fission and fusion, energy storage, energy materials, and much, much more. As the only multi-program national lab in Appalachia, we also feel a special responsibility to reach out to our neighbors, and our partnership with the Appalachian Regional Commission has helped us open our doors to hundreds of students and teachers. In fact, hearing Andy mention it's the 26th year of the program really makes me wonder what are the stories out there that have happened over the 26 years, and where have all the people gone as you're thinking about where you will go. You know, we're even at the point now where probably some of the initial grads have high school age kids who may be thinking about coming. So that's a question in my mind. Maybe we need to do a little bit of work to create an alumni network. I hope you're part of the Oak Ridge National Lab alumni network now, having spent a little bit of time here. We're very grateful to the Oak Ridge Institute for Science and Education that administers these programs under the management of ORAU, and together we're working towards a shared goal of creating opportunity in our region. We appreciate the help that you've given us this summer through your research projects. I think the enthusiasm you bring helps motivate our staff to do more, and we hope that you continue to be active in math, science, and technology, whether it be as a scientist, engineer, teacher, or just a well-informed citizen who understands better the basis for some of those big challenges that we face. So once again, congratulations, and thank you for coming to Oak Ridge this summer.
At this time, it's my pleasure to introduce Earl Gold, ARC Federal Co-Chair. Earl was unanimously confirmed as the Federal Co-Chair of the Appalachian Regional Commission, ARC, by the U.S. Senate on March 10, 2010. In the Senate confirmation hearing, Earl stated that his objective as the ARC Federal Co-Chair would be to ensure that every federal dollar expended by the Commission is an investment in the economic future of Appalachian families that will generate a return for the American taxpayer. Earl has 20 years of experience in the Pennsylvania state and local government before he joined the federal government. Prior to his appointment as the ARC Federal Co-Chair, Earl served as the Special Assistant and Associate Assistant Secretary at the U.S. Department of Labor and Director of Federal Government Relations Deputy Director for the Puerto Rico Federal Affairs Administration. Earl holds a Bachelor in Arts. You're almost out of that chair, aren't you, Earl? Earl holds a Bachelor of Arts degree from Rider College, now known as Rider University in New Jersey, and a Master's in Public Administration from Pennsylvania State University. Ladies and gentlemen, please help me welcome Earl Gold, ARC.
See if I can get this out again. You know, when we run programs like this, there are a lot of folks to thank, and I am great at missing people as I go through the list. So as I go through and talk about the work and all the help that some folks have contributed here, when I forget someone's name, I apologize right up front. But this has been a great program. I had the opportunity last night to spend some time with some of the high school kids, and you know, we've been doing this for 26 years. I think we've got it kind of down. I think we've kind of figured out how to do this, and so I really hope it was a great experience. But you know, I want to thank Kelly and Jennifer, Marie and Andy in particular for, and also Jeff Schwartz from the ARC staff, for the work and the effort that has gone into this. But I really want to thank the parents of the students who are here, that you were willing to hand over your kids to the federal government for a couple of weeks, send them to a place where they used to make atom bombs, and realize that it really provided a great lesson and really a great potential learning experience. Now, I am a experienced camp parent, camp counselor, and camper. So I know exactly what you're thinking. Your questions are, who is this guy? How long is he going to drone on for? When is lunch? Yes. And when I get home tonight, can I ditch my parents and go hang out with my friends? Well, the first question, as soon as the last picture's taken, the last certificate is handed out, lunch is right out that door and you're set to go. Your parents are going to be kind of curious about where all this energy came from. You have to remember, they've had a couple quiet days. And now all of a sudden, coming back into their quiet nest is all of this energy. My recommendation as a former camper is the minute you get in the car, begin to talk. And talk and talk and talk. And by the time you want to go hang out with your friends, they're going to open the back door. And help you go hang out with your friends. But in terms of who I am and how I want to grow up, it kind of depends. My job, I was appointed by the President of the United States, President Obama, to be his representative at the Appalachian Regional Commission. And so it's my job, it's my responsibility that every dollar we spend, that I have to approve everything. And so I'm fairly cautious about how we do things and what we spend them on. And so part of my job is to come here and to ask you a couple questions. And the quicker you answer these questions, the quicker we're out of here. So my first question for you, and remember, I'm an official of the United States government, so you gotta be cooperative with this. first question is, did you have fun? Yeah. Did you think this was like child labor? That's really good. That is the right answer. Would you like to learn some more about what you focus on here at Oak Ridge?
Yes.
You'd like to learn a lot more.
Yes.
Now, if someone told you you could make a boatload of money, yes. There are odds here, you know. If somebody told you you're going to get a boatload of money, if you learn a whole lot more, not just some more, but a whole lot more about these issues and these areas of science that you looked at, would that be interesting to you?
Yes.
Okay, well those are all great answers. Those are really great answers. Because, you know, wanting to learn about something is often called getting a passion and having a passion for something. Learning more about something sometimes ends up with a college degree, and that's good too. Learning a ton more in order to earn a boatload of money, it's called a career oftentimes. So it's really glad to hear that there are a couple of nuggets out there that can grow and, you know, might grow into a college degree. Now, at the Appalachian Regional Commission, we call all of this an investment in the future of the Appalachian region. And that's why we've been doing this for 25 years. Because we've taken your mom and dad's and your grandparents' tax money to provide for a camp like this. Because part of our career and part of our job is to plant those seeds throughout Appalachia so that your communities can reach their potential. Now here's the bad news. And remember, I'm from the federal government, so you're going to need to do this. There's an assignment here, there's a homework assignment. That nugget you picked up this summer needs to grow. It needs to be watered, it needs to be nurtured, and that's something that you and your parents are going to need to do together. So my assignment to you is to make sure that that nugget grows. And that if it grows to the point of earning a boatload of money, that's great. But I'll tell you what it's also going to grow into. It's going to grow into a lifetime of great opportunities. And that's what's so exciting. I want to thank you all for coming the last 4 weeks. I hope you had a great time. And it's so important to keep that nugget alive and keep it growing. Thanks so much.
Good morning. My name is Kelly Ramey, and I'm the program manager for the, let me get this right, the ORAU Middle School Science Academy. And our students this week have been investigating different forms of alternative energy, and I know that they're really excited to get up here and share their experiences with you. But before they do, I want to make sure and recognize our master and resident teachers. Now, these ladies and gentlemen are outstanding educators, and they're the ones that really make this program happen. And it's been my privilege to work with such a caring, compassionate, excellent group of educators this week. So if you guys would please stand when I call your names. Janet Donaldson, Brent Lee, Lauren Wilmuth, Kayla Canario, Ruben, and Elaine Vaughn. Would you give these guys a round of applause? Okay, so our Science Academy groups, they're going to make some presentations on their experiences and the things they've learned this week, and we're going to go ahead and start with the solar group. So if you guys would come on down.
Hit this button? Okay. Hello and welcome. We are the Solar Energy Group from the ORAU Summer Science Academy. Our instructors were Mr. Brent Lee and Dr. Elaine Vaughn. Lost my place. I hope you enjoy our presentation about solar energy. Ellie will now talk about PN junctions.
I'm Ellie, I'm from Harriman, Tennessee. PN junctions are when there is an imaginary boundary and the positive parts are on the N-type silicon side and the negative parts are on the P-type silicon side. When the imaginary boundary is gone, it is called a depletion region, and the parts travel to the other side. And there is also a moderate field. When you connect the forward bias to the silicon's N and P types, you will allow the electrons to flow across the bias. This is how we collect excited electrons, also known as electricity, to be used for a variety of electrical energy needs. Emma, are you ready to tell us about series circuits?
Why, yes, I am. Okay, so as Ellie just said, actually, I'm Emma Stamper, and I'm from Moorhead, Kentucky, and I'm going to be telling you about series circuits. Well, you're probably wondering, what is a series circuit? A series circuit is a system of connecting panels in a way that the amps stay constant and the volts are added. Then both are multiplied to find the total watts. It looks something like this. The panels are placed negative connected to positive, not negative to negative, or positive to positive, so the electricity can transfer. Now for Santana and parallel circuits.
Hello, my name is Santana and I'm from Notasulga, Alabama. In the parallel circuits, the amps add as you go along and the volts are constant across the whole circuit. Parallel circuits are mostly found in homes. Parallel circuits and series circuits can connect together. Parallel circuits can be used in different ways. It is an electrical circuit which allows the current to flow when part of the circuit gets interrupted. And now Louis will talk about the data we collect and analyze from our solar panel testing. Louis.
Hello, students of Oak Ridge ORAU Science Academy. My name is Louis Corcolone, and I'm from Jamestown, New York. On Tuesday, July 21st, 2015, we did some testing on solar panels, and here's our data. These are our estimated calculations for our data. Finally, we put both of the groups and put together in a table like this. And now Trey will talk about the solar farm and the solar house we visited.
My name's Trey, and I'm from Meigs County, Tennessee. On Wednesday, the solar group went to a solar farm in the Living Lighthouse. At the solar farm, our guide told us about the farm and how the panels work. One of the facts that I thought was cool was that this solar farm contained 4,600 solar panels and powered over 150 homes in the area. We saw all the panels. We also went to the Living Lighthouse. It is basically a house completely powered by solar energy. Well, one fact was that you didn't even need any power to keep the house cool or warm due to the special doors and windows. And now Kaya will talk about the pros and cons of solar energy.
Hi, I'm Kaya. I'm from Hawley, Pennsylvania. Solar panels produce no carbon and need no fossil fuels. After they are installed, the solar panels are almost completely self-sufficient, but there are downfalls. Cloudy days affect electricity production. Solar panels are expensive to install, but eventually save money per unit. About 10 acres produces a total of 1 megawatt. As you can see, some parts of the U.S. get more light energy than others. The darker the color, the more kilowatts per square meter. Branson, will you tell us about the worm gearbox?
I'm Branson. I'm from Andrews, North Carolina. This week we did the worm gearbox. It was fun and hard. We had to look at the pictures because none of us could read the directions. It was in Japanese. We had two choices for the speed. We had slow, which was what a couple of us chose, and then a couple of us chose really slow. The really slow one. but it was fun and we successfully completed the job. Our solar panel turns the rays of sun into electrical energy, and then the worm gearbox turns it into mechanical energy. Now Mary will tell us about our inventions.
Hello, my name is Mary Armando. I'm from Chatsworth, Georgia. The solar group used the worm gearbox to make an invention by using solar power. Some students made a fan, blow dryer, solar house, and even a gear walker. These inventions are powered by solar panels. They attract energy to make electricity and then make these inventions work. The students research information on solar power and how they work to provide them with the knowledge to create their invention. These solar-powered creations are examples on how solar panels really work. We would like to thank Mr. Brent and Miss Elaine, our Academy counselors and instructors, Mr. Thomas McManaway for giving us a tour of the solar farm, and Mr. Bucky Smith for the visit to the Living Lighthouse. Thank you for giving us an opportunity and making this week unforgettable and very special. And now the WIN group will tell us about their week.
Okay, this is called a worm gearbox, but I named it the Gear Walker. It pretty much just has a solar panel right here, and it powers this engine, and then it moves the gears, and it just walks.
Okay, and I made a solar-powered fan. The gearbox is back here, and then the solar panel I just glued on the back. And my speed was slow, so it doesn't go that fast, so there's no wind actually produced, but you know, what are you gonna do?
Hi, I'm Aaron Gillespie from Liberty, South Carolina. I'm a member of the WIN group. This week, our group learned the key role that wind can play in providing us with unlimited renewable energy. Our task was to design our own wind turbine. We have found that teamwork made this task a breeze. What is wind, you may ask? Well, wind is the natural movement of air at any velocity. Now let's hear from Larkin, who will tell you all about the advantages and disadvantages of wind energy.
Hi, I'm Larkin Gardner, and I'm from Water Valley, Mississippi. I'm going to talk to you about the advantages and disadvantages of wind energy. Here are a few advantages. Wind energy doesn't create greenhouse gases or any other pollutants. The wind is a renewable resource and is completely free. The wind turbines that make the wind energy are very tall, but they take up a small amount of land. The land below can still be used for other purposes. Some people have problems with the amount of noise a wind turbine makes, but I stood right beside one and it didn't sound any louder than my air conditioner. Although the wind is free, the making of the wind turbine is pretty expensive. If you live near a wind turbine, then you're probably familiar with the turbine blades casting spinning shadows through windows. The shadow flicker gets on some people's nerves. Now it's up to you to decide. Are you a fan of wind energy? Now Summer is going to talk to you about our trip to Buffalo Mountain.
Hi, my name is Summer Dracup, and I'm from Jamestown, New York. I'm here to talk about the wind farm my team visited during this program. We met with the site manager of Buffalo Mountain, Carl Eierman, who gave us some insight on the turbines. The Invenergy wind power site is on Buffalo Mountain near Oak Ridge, Tennessee. The site includes 15 wind turbines that generate more than 20 megawatts of power per year. This is enough to power almost 4,000 homes for a year. This wind farm has been open for 11 years and counting. Here are some statistics on the turbines. The gearbox is 39,000 pounds. That's about the weight of 2.5 elephants. The height to the nose cone is 262 feet. That's only 38 feet less than a football field. Also, the life expectancy is 25 years per turbine. So as you can see, the wind farm on Buffalo Mountain is an amazing, mind-blowing, and beneficial sight. Now you'll hear from Gabrielle with the parts of a wind turbine.
My name is Gabrielle Rue, and I'm from Landrum, South Carolina. I'm going to be talking about the different parts of the wind turbine. There are 6 main parts. There's the blades, the nacelle, the gearbox, the generator, the tower, and the base. The blades are the extended panels that spin when the wind blows. The nacelle is the covers for the pieces like the gearbox and the generator. It protects it from the elements. The gearbox connects the low-speed shaft with the high-speed generator and makes the rotation a lot faster. The tower is the long pole that holds the blades and the nacelle in the air. We need a tower to get the turbine high in the air where the wind speed is stronger. The base is the bottom of the turbine that keeps it steady. A few other parts are the anemometer, which measures the wind speed. The rotor is the triangular part that sticks out from the blades. The hub and the blades together make the rotor. All these parts work together to make eco-friendly energy and power homes and farms. We will now go to Josh to talk about the process we use to make our wind turbines.
Hello, my name is Josh Loomis and I am from Jamestown, New York, and I will be telling you about the design and construction of the base and blades for our wind turbines. For the base, we used a variety of different styles of PVC pipes. After building the base, we set about the process of manufacturing our blades. The materials we used in this process were corrugated plastic, balsa wood, styrofoam, and aluminum foil. We designed the blades in order to make them as aerodynamic as possible. By adjusting the pitch or angle, size of the blades, shape, and materials used, we were able to determine the combination generating the most energy. We had lots of fun designing and making our blades and base over the last few days. I hope this information blew you away. I will now turn over to Reese.
Hi, I'm Reese Yost from Tazewell, Virginia. We first tested our blades in the classroom to make sure that they would work and to check to see if the pitch or angle was correct. Most of the blades managed to work. Some even hit more than 20 milliwatts. After testing our blades in the classroom, we moved on to testing at a NOAA, or National Oceanic Atmospheric Administration wind tunnel. Gabriella won at the wind tunnel with her Batman blade design with an astounding 19.36 milliwatts. Now I'll let Austin wrap things up.
Hello, my name is Austin Malin, and I'm from Andrews, North Carolina. As you can see from my colleagues, we have accomplished a lot this week. We've learned about the pitch of the blades and how they affect the overall efficiency of the wind turbines. We've learned about the parts of a wind turbine, and we've also learned about the statistics of wind energy. The group and I have even gone to a small wind tunnel and to a wind farm. I do believe that I'm speaking for everyone in my group in saying that we have had a time we shall not soon forget. The group would like to thank Carl Eierman for being an amazing guide on the Buffalo Mountain Wind Farm, Mr. Mark Rubin and Miss Lauren for leading us in this experience, and Rob Dobsey and Randy White for allowing us to use their wind tunnel. And of course, I would like to thank everyone here for allowing the students to be taught and for coming out here to the Secret City to see our projects. And at this time, I'll turn it over to the Biofuels group.
Hello, ladies and gentlemen. I'm Randy Boyer from Calhoun, Georgia, and today we'll be telling you about biodiesel. There are multiple energy sources used to power vehicles of all types. The most widely used energy sources come from petroleum. There's gasoline, diesel fuel, liquid natural gas, and propane. There are also alternative sources under research such as electricity, biodiesel, and ethanol. Diesel is the most commonly used fuel in commercial vehicles. However, a process has been developed in which fuel can be made from vegetable oils and animal fats. This week we specifically focused on biodiesel, and then we made it. The vegetables we used to make our biodiesel were canola, corn, soy, and sunflower. We're going to tell you how we made biodiesel, what we learned, how biodiesel is being made now, and the pros and cons. And this is corn oil being burnt now. And now Tanaya is going to explain the procedure.
Hi, my name is Tanaya Hawkins, and I'm from Water Valley, Mississippi.
Biodiesel is easy to make. Different samples of vegetable oils were used and mixed with methanol and potassium hydroxide. This mixture was poured into a separatory funnel and it was flipped and burnt. Once it was into 2 layers, the bottom layer was drained to remove excess methanol. This step was repeated with methanol and water several times. Then the biodiesel was placed on a hot plate to remove excess water. And now Bobby Ann will finish the procedure.
My name is Bobby Ann Moore, and I'm from Chatsworth, Georgia, and I'm going to be finishing the procedure. A wick was placed into a petri dish and a small amount of biodiesel was added. After recording the starting temperature, the petri dish was placed under a sample of water. The wick was lit and the temperature of the water was taken. We were able to use a program that measured temperatures and recorded it on a graph. The cords got in the way, so we printed a clip on a 3D printer to help. Now Anthony is going to tell you the results.
Hello, my name is Anthony Severs. I am from Marietta, Ohio, and the first graph shows 4 replications of corn biodiesel. And this slide shows the same replications for soybean. And this graph shows the 4 applications for canola. Okay, this is the replications for sunflower. The average change in temperature per grams of fuel and for the 4 different oils is shown here. And as you can see, soy is higher. So now Michelle will tell you about the analysis.
Hi, my name is Michelle Adkins. I'm from Griffithsville, West Virginia. In general, our results are reproducible. The lines on the corn graph are close to each other. This exhibits that all variables were kept constant. The soybean graph shows a slight deviation in the first run. The group felt like stirring was inadequate. On the 4th run of canola, the entire wick caught fire instead of just the tip. This caused a higher temperature and the line to be far above the others. The lines on the sunflower graph were spread apart from each other, meaning the data is less accurate. Some of the factors causing this are the time the match was lit, hot spots, and the amount of fuel. The standard deviation is located under the bars on the graph. As you can see from the graph, the standard deviation was relatively small for canola, corn, and sunflower, but large for soy. Now Zach will tell you about the pros and cons.
Hi, my name is Zach, and I'm from Campobello, South Carolina. The thought of biodiesel today sounds like a daring thought, but it has its perks. Biodiesel, unlike many petroleum-based fuels, has fewer emissions that could potentially harm the Earth's atmosphere and the people and animals living there. Biodiesel, though, does gel faster in colder temperatures than regular diesel and gasoline. If the fuel that you are using gels, it gets harder and harder to drive, and eventually your vehicle won't drive at all. Diesel and gasoline are not renewable because we are using them up faster than they are regenerating. Biodiesel is made of plant oil, though, and the plants can grow fast enough so that they are abundant or a renewable source. Even though this biodiesel trend sounds very positive, many people are skeptical over the fact that so much of our plant resources will be used for this new biofuel. Instead of exporting corn to a country that is starving, it would be used for fuel for our cars. Yes, we will become more independent from foreign countries that we depend on for crude oil, but it will also take up a good amount of farmland that could be used for farming food for our country. There's one thing that could solve the problem, though: switchgrass. Switchgrass is a non-edible substance that can be made from biodiesel, that can make biodiesel. Though there is an equal balance of good and bad, biodiesel can be a healthy alternative to the normal petroleum-based fuel. Now Nick is going to talk about biodiesel today.
Hi, my name is Nick Craven, and I'm from Corinth, Mississippi. I'm going to be talking about some new ways that biodiesel is being made. So, biodiesel production has seen an increase of over 90% over the past 10 years. This is partially because there are so many different ways to make biodiesel. For example, in Spain, trash is being produced into fatty acids that can be made into biodiesel. Also, algae with an oil content of over 50% has been made into biodiesel, while the dried out remainder can be made into ethanol. Biodiesel made with oils that don't come from vegetable oils are useful because it doesn't waste food products. Jatropha is a poisonous shrub that doesn't produce vegetables, and it also increases the amount of oil per acre of farmland. Through molecular breeding, the plant has become more resistant to pests and diseases, as well as tolerance to colder weather. At the University of Nevada, researchers successfully made biodiesel from coffee grounds. The process of making biodiesel out of coffee grounds has been estimated to cost about $1 per gallon, and coffee could potentially make 700 million gallons annually. Now Wesley is going to talk about our trip to the NTRC.
Hi, my name is Wesley Conklin, and I'm from Pennsylvania. The NTRC or the National Transportation Research Center, is a government facility that uses their various sources of technology to improve the transportation that we use in our everyday lives. The NTRC tests things like how certain fuels would work in certain engines. And when we got to go there, they had a tractor-trailer engine, and we also got to see a BMW engine as well. The NTRC is also working on a replica of a military Jeep, but instead of just running on just gas, it is a hybrid. The University of Tennessee also had a member who worked on the EcoCar too, and she was there to explain how they turned a Chevy Malibu into a hybrid and why it is better than just to run on gas alone. The university is also planning to work on a new 2016 Chevy Camaro over the next few years. We also got to visit the MDF, or the Manufacturing Demonstration Facility. The MDF has created cars and many other things inside their 3D printers. One of their cars that they printed was a Shelby Cobra. The 3D printers they have allow them to build with many different materials, including metals. At the same time, the 3D printers can increase the speed of production of their certain projects. The Biofuel Group would like to thank Scott Curran for spending time with us at the NTRC. Also, on behalf of the entire middle school ARC Academy, we would like to thank Jeff Swartz, Earl Gohl, Kelly Ramey, Marie Westfall, and Pai Mao. Thank you.